All right, welcome back to the loops slides. We're going to finish these up and then start some new ones today. I'm going to give you probably the fanciest example that we've had so far, and it's going to be very, very useful because your lab's going to have you do the same exact thing. So let us figure out how to turn C++/rterminal into a graphing calculator. So we would like to graph a circle on the terminal, okay? So here's our terminal. We would eventually like to do this. We would like to figure out the axes, of course. Maybe we should center the circle at 0, 0. Like here's our coordinate 0, 0. Maybe we can draw a plus sign there. That's what I would like to do eventually. And then we're going to use stars to draw a circle. And it's going to look really, really cool. I promise. So that's the idea. That's what we want. How do we make it happen? So we're going to need some assumptions about our window, our terminal window, because I think you can imagine that you can rearrange this, you can resize this to whatever you want. When it's default, I think it's 80 by 24 or something. So we'll be close to that. Let's stick near that. So let's assume that our window size, at least in the lab, this is what we're going to do. Our window size is 78 wide by 24 high. Okay, so width equals 78, height equals 24, and the idea is we would like to use this to our advantage and center like the middle coordinate and make that be our 0, 0 for our graphing calculator. So that means that, I don't know, this is the y equals 0 line, this is, no, sorry, x equals 0. Dun dun dun. And that means, for example, like this is our y equals 0 line, and like this is y equals 39, this is y equals negative 38. Because we're centering it this way, oh sorry, those are way too big. Y is going to range between negative 11 and 12, so this up here is 12, and this is negative 11 down here, this is the last column. And then x is going to range between, like, definitely there's 0, x equals negative 38, and here is x equals 39. So the idea is we're going to use a big nested loop. This is just like printing a box, believe it or not. It's just a very complicated box now. We're going to figure out each case, should we be printing something for this line? Like we're going to start up here. Try all of these different characters, like, hey, should we be printing the star here? Hey, are we in the middle? What coordinate are we at? Things like that. Okay, so it's really going to work out like that. And so it's just like printing our box. And let me go and prove that to you. Let me prove you that fact. Let's make a box. Let's draw a box that is 78 by 24. Okay, and let's see the similarities. Let's do that. Circle.cpp. Dun dun dun. Alright, so I'm going to draw a 78 by 24 box. So the first line is going to be, I'm going to draw 78 characters. I'm going to do that 24 times, yeah? For int I equals 0, I is less than 24, because that worries about which line we're on. We got 24 lines total, 24, and then we're going to do that. Draw 78 stars on each line. For int j equals 0, j is less than 78, j plus plus. Oops, sorry, I forgot the I plus plus, and that's that. And then we'll just print stars. And then a new line. Okay, so this is going to be a giant box of, if I could get to some G++s, there we go. It's just going to be a giant box that covers the entire terminal. So here's my boxes. It's covering most of the terminal. So let me resize this to make it a bit bigger. So you can see, here's my little screen. Just a bunch of stars. So we used I to represent which line we're on, and J to represent which column we're on a given line. So the idea is I is like Y, because that figured out which line we were on, and J is like X. That's the current column. You put them together, and you get a coordinate. I is like Y, J is like X. And so let's not have I and J range between, instead of it being like 0, 0 and 24, 78, let's instead make it 12, negative 38. You see that? So this is going to be our coordinate up here. That makes the center right in the middle. Let's turn that into, bam, 12, or Y equals 12. X equals negative 38. And let's have the bottom right corner be X equals 39, Y equals negative 11. So that's not too bad. Let's change that now. So I is Y, and J is X. Y, X, Y, X. And Y needs to start out at 12 and go all the way down to negative 11. So we're going to decrement. Okay, 12 greater than or equal to negative 11, Y minus minus. And then X is going to start out at, on each line, negative 38 and go to 39. So that can stay increasing. Okay, so that doesn't change anything. Let me prove that to you. It's just the values that Y and X are taking on. We're not using Y and X just yet. So it still draws the same box. Okay, same stuff. We're just using different values for these variables, and that is going to center our graph. So now 0, 0 is right smack in the middle. And let's prove that. Let's print a plus sign at 0, 0. Are you ready? So instead of this, let's say, I don't know, you sure that's fine, but if X is 0 and Y is 0, let's print the plus instead of the star. Yeah. Okay, so if we're smack in the middle, print a plus, otherwise print our stars. And I think you can see it. Right in the middle, there's our 0, 0 axis, and now we're going to draw a circle around it. Aren't you excited? I sure am. So here's the game plan. We're essentially there. We've got our coordinates set up that we're going to try all these things in order. All we next have to do, the last thing we have to worry about, is just drawing our particular stars along a circle. However, shall we do that? Well, let's pick a circle. This is, remember, this is the equation for a circle, and we can determine things that are on that line, on that curve, by seeing if they respect this equation. Okay, so that's my hint. Let's pick a certain circle. Let's pick the equation x squared plus y squared equals 10 squared to graph. Okay, so the radius of our circle will be 10. And so we're going to need to figure out which coordinates are part of that circle. And all we need to do once we know that is to check whether our current xy coordinate matches that equation and print a star if it's on the graph. Okay, so a lot of the time we're going to be up here out in the weeds printing spaces. But once we get on the graph, we're going to print stars. And once we get to the middle, we're going to print a space. Okay, so that is the idea. So let me go back out to this and comment this up. So we currently have an xy coordinate. Right now, see if it's on the graph. If so, print a star. Otherwise, if it's 0, 0, print a plus, and then otherwise print a space, just so that it's empty there. Like the graph is empty, we're not plotting anything there. Okay, so are you ready? Let's do this. How do we figure out if we're on the graph? So we just have to check well, all we have to do is check is x squared plus y squared equal to 10 squared. That totally works. But we're going to run into decimal issues, so we need to instead solve for y. So that we have like something to actually check for. Y equals plus or minus the square root of 10 squared minus x squared. And so if we plot both of these, it will work. So we have an xy coordinate. This is the game. We have an xy coordinate. We check if that y is currently equal to the square root of 100 minus x squared. So x times x. That is a star, x times x. As long as we check that and plot if so, that's how we know. That's how we know if this xy needs to be graphed. I hope this is making sense. We're just checking if our current coordinate is on the graph. If so, we'll draw a little star. Okay, that is the idea, and eventually enough stars will make the circle. So hopefully this is making sense. And now we just need to follow our comments. So see if our current xy is on the graph. Otherwise, see if it's the origin. Otherwise, it's just empty space. So if, are you ready? If y is equal to the square root, and let's include CMath, done. If y is equal to the square root of 100 minus x squared, well, in that case, we're on the graph, print a star. Else if we're at the origin, x is equal to 0 and y is equal to 0, in that case, print a plus, like just show the axes crossing. Otherwise, we're just in an empty space, and we'll print a space so that we continue. Okay, we'll still print the new line once we're at the end of the line, so we go on to the next one. And that's really that. So let's try this. There's a bit of a problem still, but we'll get there. Yay! So it's almost a circle. It's a bit squished because of the way things are working. Because every character is a lot taller than it is wide. It'll be a little bit oval shaped, but it's almost there. We're just missing a few. And why is that? Well, the issue is square roots. That's returning doubles. I'm actually doing this in a weird way. I'm comparing integers to usually things with decimals in them. Sometimes it's perfect, and we get all these points that are in our circle. But a lot of times it's not. So the way that we can fix this is to be a bit lax, to squish those decimals onto integers with our round function. So if I round all of this, that will actually fix it, okay? So I'm squishing those decimal places onto integer coordinates. So it's just an approximation, but it still works. Still works quite well. And so we went from there to there, and this makes it a lot easier to do that. So, and this is how we can check. Are we on the graph? Let's round now to make sure that if the square root ever gives us back a decimal value, we'll always hit some integer value. We'll hit the closest one. round to the nearest integer xy coordinate on the graph. Okay, so that's what this does. So we round that square root. Are you ready? We did it. So this is the top part of the graph. You see that? It's beautiful. And so it's always hitting it for each different x coordinate. There is a y coordinate that's on this graph. And it's drawing our circle. It's beautiful. But this is only the top part of the circle, right? So I draw we just plotted the plus 10 square root of 10 squared minus x squared. We need to also plot the minus. Okay, so that's the idea. Are you ready? So that's the top of the circle. Let's do the bottom of the circle. So it's going to be an else if again. And it's going to look like, let's see here. There we go. So it's else if again, and it's y equals like negative around all this stuff. Okay? So this is the bottom of the circle. Oops. So graph the top of the circle, graph the bottom of the circle. So it's in one of those. Otherwise, graph the origin or just an empty space land. Yay! And I hope this is very fulfilling and rewarding, because we have just graphed a circle, and we can graph any function we would like to graph on the terminal. It is our graphing calculator. Okay? So pat yourself on the back. Give this a try. Make sure this is making sense to you, because this is going to be your lab. You're going to write the body of this. I'm going to give you all the loops and everything, and you will write the body to graph a certain function. Okay? So this is us graphing y squared plus x squared equals 10 squared. A radius 10 circle. Isn't that fun? Okay, yeah, that's everything that I wanted to show you there. That's graphing a circle, and that'll come in handy for your lab. And that brings us to the end of these slides. So for some exercises, one that I would like to do with you is this one. Let's translate this nested loop into a flowchart diagram. So like there's some stuff that's executed before, and some stuff that gets executed after. Oops, after. And let's translate this to a flowchart. So we start from before, then we come into the while loop. And the first thing that we do to execute a while loop is to always check its condition, because that tells us whether or not we should do the body. Okay? So we'll check that A. Is A true? If it is, we now have to do the body of the while loop, which is this entire for loop. And do you remember how for loops execute? Well, they do their initialization, then they check their condition. If it's true, they do the body and then the increment. E, F, and then it goes back to the condition. And eventually it'll become false, at which point we can go back to the condition for this loop. Whee, so that's false, if it ever becomes false. And yeah, that is the idea. It's going to keep on going around, execute the for loop as long as it needs to until it's done. And then it'll go back to the while loop. And that'll keep on executing that for loop until it's done, do another iteration of the while loop, so on and so forth. Until that condition A finally becomes false, at which point we are done with the whole loop, and we don't execute the body anymore, and we go to the after. Okay, so this is something that I want you to get good at, and slowly but surely, with enough examples, you will. So that is my example for you. Next, some very, very important things that I'd like you to try yourself are to write 4 different kinds of infinite loops. There's a lot of different ways, like while true. While true is one of them, but there's plenty more. And try and come up with some common ways of getting infinite loops that will help you avoid them. And then finally, maybe you can write a program that solves this using brute force. So try all the possibilities, find the first n greater than 100, just try all the numbers starting at 101. Dun dun dun. So like, I don't know, whatever it is, it's 101 onwards, figure out where it is, until it becomes true that this fancy number, n cubed plus n squared plus n plus 1, is divisible by 555. Okay, try that, and let me know if you have any questions. So that is the end of these slides, and I'd like to move on to the next ones now. So I'm going to go load those, and I'll be right back. And welcome! These slides are about arrays and vectors. Let me confirm that I'm actually recording, yes. And they're exciting because they're going to allow us to hold a bunch of stuff. All right, so let us get started. Let me show all of that to you. Okay, so arrays versus vectors. There's two concepts here, and they're very similar, but they're slightly different. So both of them, all this stuff that I'm going to talk to you about in these slides, they teach you how to hold stuff, a bunch of stuff together, because we've had a bunch of variables so far. They're kind of apart from one another. We don't like that. We'd like to bring them all together, make them have a little family or something. And one thing that I'd like to just point out right now is that unless you're like doing very low-level stuff where you don't have a lot of memory, or you have some very bad guarantees about things, or you're doing multi-dimensional things that we'll talk about later, you should almost always be using vectors, okay, instead of arrays. But arrays I have to teach you first so that you understand what vectors are. So yeah, we're going to put a bunch of stuff together instead of having a bunch of things be separate. That's essentially the idea. Okay, so the first thing that I want to talk about is arrays, and they are wonderful because maybe you've come across this already and you want to know if there's a better way, and there is. So let's pretend we have this problem. We would like to ask the user for 50 numbers, please, and then we're going to print those out in the order that they gave them to us. So say if we typed 42, then 37, then 3, then 13, it'll just spit them back out to us in order, so it needs to save them all. Okay? So what we have to do right now is this. Dun dun dun. Let's declare 50 numbers, and then we'll get them from the user. And that's going to be essentially our program. Then we'll print them back out, right? Oh man, that sounds horrible. And even if maybe we want to sort them, like, okay, the 3 comes first, then the 13 comes second, then we have to do some weird stuff with 50 variables. No, no, no. We do not like that. Sam, we are. Okay? So the solution, enter arrays. All right? So an array is just one variable. It's one thing, one entity. It has one name, but it holds a bunch of little things. Okay? It holds a list of data items of the same type. Let's put that in bold. That's very important. Each being directly accessible. What in the world does that mean? I will show you. So an array looks like this. If I can draw it. ARR. It's a big long box of things, and it has little tiny fields, okay? And each item in an array is called an element, okay? And directly accessible means that we can index into our array using these little bracket operators. So, for example, let me show you this. Ignore. This is a declaration of an array of ints, okay? This is how you read this. It's an array of 7 ints. ARR is an array of 7 ints. And this is what it looks like in memory. It has 7 things, 7 boxes. 1, 2, 3, 4, 5, 6, 7. Okay? And we can put whatever we want in here. Right now it's all undeclared because we haven't given any real value, so these are all like question marks. And we can access any individual piece of this just like we would a string, remember? It looks almost like a string. Oops, what just happened there? So again, it starts at 0. 1, 2, 3, these are all the indices. But you use these little brackets now to index into like the array at 2 to get the value there, yeah? So that is that idea. So let's move on. declaring and initializing arrays. So what we would like to do is both declare an array, yes, this array ARR, it exists, make it be so. We would also, in addition, like to give it values. That would be nice to put values into it. So yeah, this is what it looks like to declare an array. You always say something like the type, like int. This is the type of things that go inside of the array, and then you give it a name, and then you give it its size. Okay, so for example, int ARR of 3, for example. It's an array of ints, an array of 3 ints. And right now they start out undefined. They don't have a value yet, but we can give them values. Yeah, so just remember they're filled with garbage, just like every other variable. It's just 3 garbage values, not just 1 anymore. So you can change the index with the following. Why in the world is it complaining? You say the array name at index I, please make that 42. Okay, so I can say array of 0, please make that 1, and that'll go in here and change it to be 1. Yeah. So this this indexes into the array, we say, and sets the value. And set the value. Okie dokie. So that is the idea. You could also, alternatively, instead of having to do a bunch of these lines, you can declare and initialize just like you could any other variable. So you can say, like, the type name, the array name, and then the size equals braces 1, 2, 3, and that fills in the array of size 3 with these 3 values. Okay? So that creates this ARR, initially holding 1, 2, and 3, not undefined anymore. Okay, so that totally works, and that's int ARR of 3 equals 1, 2, 3. Maybe I should have given myself more space here. Let me move some stuff. Go over here, please. So that is this right here. 1, 2, 3. That's a brace. Okay, so that produces this array. Alternatively, you can actually just drop the size if you're going to give the values, because it knows, like, I'm the compiler, I can count 1, 2, 3. Sure, I'm going to put 3 things, I'm going to make your array of size 3. Okay, so for my next trick, I would like to show you a demo. Let us get the 10 numbers from the user, and we will print them back out. Okay, so I'm going to make an array. I'm going to make an array of size 10, and remember that those indices start at 0. So this is what it looks like in memory. Let's see here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. That's 1 too many. 7, 8, 9. Excuse me. This is 10 indices total. That's what array looks like, ARR. And we're going to fill that in with the user's stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we will, I don't know, we'll initially print them back out, and then we'll do some more cooler things with them. Okay? So, that is the hope. That is the hope. So let's get started. Let's declare our array of size 10, and then do cool stuff with it. Let's fill it up from the user. Okie dokie. All right. So int ARR size 10. So ARR is an array holding integers, holding ints with 10 indices. Remember that they go from 0 to 9. Yeah? And now we need to use it. So we're going to ask the user to enter 10 things, please. we'll do that, and then we'll cin all of them. You can say cin, please enter array 0, then array 1, but no, we can use a loop for that. So for int I equals 0, I is less than 10, I plus plus, cin arr of I. So cin each into each index of the array. Because the first time I is 1, we'll cin into array of 0, arr of 0. We'll get the 0th index and set it using cin. Yeah? It just works like any other variable. It's just arri is an int. We can index into it and get an int. Okay, so that fills the array. Now the array arr is full of things. Let's print them back out. So again, I can say cout array 0, new line, array 1, new line, etc. But again, we can use loops. We can say array I, and do it all over again. So here's that, here is that, and we'll print them all back out. Okay, hope you see that. Actually, let's print them all on the same line, because why not? Maybe a space in between and then a closing end line at the end. And let's make this smaller so that we can all see everything. There we go. Oops. All right. Enter 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Enter. And bam, it saved them, and it spat them right back out. Now we can do this in any order, like, I don't know, 1, 12, 3, 4, 5, 6, 17, 8, 9, 10, and it just remembers them all always, and it prints them out with spaces. Okay, so that is the first thing that I wanted to show you with arrays. So it's just one thing now. It's one variable that holds 10 little things, 10 integers. Okay? Let's get the sum now. So we'll need a sum variable to keep track of this. We'll be like sum, start out at 0, and then add in each index into it. Yeah? So it'll start out being 0, then we'll add in the 1, so now sum is 1, then we'll add in the 2, so now sum is, oops, so now sum is 3, then we'll add in the 3, so now it's 6, etc. So let's figure this out. Start out at 0, that's the initial value, and we'll keep on using this sum variable and add into it arr of I at each time. Okay, so add in each arr of I. So add in each index of arr I into sum. Sum equals sum plus that new index. So we'll try them all because I is going between 0 and 9, and we'll add in each of them into sum, and we'll print out sum again. Okay, let's see. Well, it's going to depend on what we type in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The sum is 55, which makes sense. It's 10 times 11 over 2. Yeah? Whee! So that is correct. That's beautiful. We just got the sum. How about the minimum? How are we going to do this is the question. Let me tell you the secret. Maybe you would like to think about it a little bit. The idea is we have to, like, we don't know where the minimum is going to be. Like, the array could be, this could be like 111, and maybe the minimum is 2. The minimum could be anywhere. Yeah? So we must check every index. So, I don't know, how do I want to say this? Yes, we must check every index because the minimum could be anywhere. So we have to go through array 0, array 1, array 2, try all of them and see which one's the smallest. Okay, so the game is, well, first we're going to make a guess. We're going to guess that the first index is the minimum. Maybe it is, maybe it isn't, but that's our starting point. Okay, so save our current guess for the minimum. And start that at the 0th index. And we'll update our guess as necessary. Okay, that is the hope. So we're going to start out the min being the first value, 1, and then we're going to update it if there's ever like something smaller, like maybe this is 0 or something. Eventually, we'll update it to 0 if we ever find a smaller element, because we're going to try every single one. We're guaranteed to eventually find the minimum, but it might take a while. We might have to see, we might have to look through the entire array, because maybe the minimum is the final thing. Okay, so that is the idea. Let me write it to you in code now. So this is the hope. We initially make a guess. That the 0th index is the minimum. Okay? So we say int min equals array 0. So this may or may not be the correct min, but we'll update it. We'll just keep on updating it. And so then we have to try every index again. For int I equals 0, I is less than 10, I plus plus. Technically we can start at I equals 1, because we've already set min to be 0. We don't have to look at it again. Alright, so now we'll start looking at 1 and see if we find a smaller value. If we do, update our guess for the minimum. Okay, so this is how you do it. If the index that I'm currently looking at is smaller than the minimum, then my guess for the minimum, update it. So that means minimum, well, our guess should be ARRI'd now. Okay, because that was smaller. Okay, update the guess. And this will work. This is going to work out as long as you try everybody. As long as everybody has a chance to have this if statement go for them, eventually we're going to put the smallest thing in the min variable. Okay, so once this is done, once we've tried everybody, once this is finished, we have the proper min, okay? Okay, so we can print it out now. So we did all this work. We started with our guess being the first thing, and we're going to keep on updating it, because maybe it wasn't the first thing, like maybe there's a 0 over here, in which case, well, 2 wasn't smaller, 3 wasn't smaller, 4 wasn't smaller, 5 wasn't smaller. Oh, 0, that was smaller. We're going to set the min to be 0 now. That's the game. Not too bad, I hope. So let me prove this to you. So sometimes it's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minimum is, of course, 1. It's the first thing. Other times, 2, 3, 4, 5, 6, 7, 1, 8, 9, 10. The min's way over here. Yeah? Or like 1, 2, 3, 4, 5, 6, 7, negative 42, 9, 10. It will eventually find it, even if it's the last thing, because because it's going to try every element of this array. It will eventually find the smallest one, even if it originally guessed wrong. Like 1 wasn't the smallest. It will eventually get replaced with the smallest thing because of this if statement. Okay, I hope you see that. Do study this. It's very important. And then with that, I think we can move on to the next slide, which is a fun one. It's about this wonderful, wonderful, horrible, horrible thing called undefined behavior. Okay, so let's talk about it. It's very unfortunate, but it's good to know about. It will ruin your day, and I'm sorry, but it's good to see it because now I can tell you, okay, yeah, this is undefined behavior, and then you can be like, oh, darn. Okay, so you can access / set array at index 5 when your array is size 5. And that should make you sick, because if array has size 5, what are its valid indices? Do you remember? You got your 0, 1, 2, 3, and 4. There is no index 5. It does not exist. It's like what would have been right here. No. You're telling me that I can access that? And it's going to give me a value back? It's not going to stop the program? It's just going to let me do this? Yes. I'm having a conversation with myself right now because this is a very, very important topic. You can access this. You can say ARR5. Be like, cout. ARR5. What this is it's whatever is after the array in memory. It's just memory that you shouldn't be looking at, memory that doesn't belong to you. Okay, so you should never ever do this, but it will probably work, assuming you're just looking one thing after it. It'll probably be another variable in your program, actually. The issue is, when you do something like this, if you look at the value, especially if you set the value, you've unchained this horrible, horrible beast called undefined behavior. So you are breaking the rules of C++. You are accessing memory that does not belong to you, and the compiler, if it ever catches you doing this, it's allowed to do whatever it wants to your code. It can, for example, it is allowed to, given the C++ language specification, it does not guarantee that it will not delete every cat picture on your hard drive. It's totally allowed to do whatever it wants whenever undefined behavior happens. So it'll make very weird things happen in your program, and sometimes it'll even stop your program. Sometimes it works, sometimes it doesn't. So let me show you this horrible thing, and that'll be it for today. Are you ready? Int ARR, I don't know, 5 equals, oh, we don't have to give it. We can say equals 1, 2, 3, 4, 5. No problem. Okay, are you ready for the horrible thing? For int I equals 0, I is less than 6, I plus plus, less than or equal to 5. This is a common mistake. Cout ARR of I. I shouldn't be doing this, but I'm showing it to you. Okay? This should make you feel very uneasy. Oops, I compiled the wrong program. Control C. Here is whatever was in memory. It took the shape of an int. It tried to read it as an integer. It was this value. We can do worse. Let's try and read 6 things. Oh yes, it was that number that was next. And if you try and write to this, it might cause your program to fail. Okay, that's extra horrible. Let me show it to you, because eventually you'll run past the valid memory space of your program. So let's make this, I don't know, 60,000? You know what? Let's work our way up. Let's print 600 things. Aha. Yes, that's exactly what I thought was in my array. Oh, a bunch of zeros. That's fun. Yeah. This is all making so much sense. Totally. Yeah. There's a little pattern going on there too. So it's just random memory of your program. Some of this is yours. The rest of it is not. We shouldn't be looking at it. And the second we go too far, 6,000. Let's try. Okay. Yes. It's eventually going to try and get somewhere. That's past our program. We only have so much memory in our program. And the second it does that, it causes what's known as a segmentation fault, which is just telling us that we access memory that we're not allowed to access. So apparently up to 600 works. But any more, like if you change the above to I is less than or equal to 6,000 on Lawton's computer, you end up getting a runtime error called the seg fault. It means you tried to access memory that was beyond the end of our program's allowable memory. Okay, so several indices past the array still belongs to our program, but several, you go a few more, eventually you're going to run into the end of the valid memory space of our program. So yeah, you can totally even set values here, and things might work, but they probably won't, and you should never do this. So remember, always, 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 to check your indices, check that you're only ever going to the end of an array, because otherwise you invoke the wrath of this horrible beast called undefined behavior. And just to keep this very weighty topic in your mind, this is where I would like to stop with this lecture. So we'll come back, talk a little bit more about arrays. We'll finish up these slides next week. Tons of fun things, I know, but you have now had a taste of arrays and vectors, which allow us to store not just a bunch of little tiny variables that are disconnected and hold just one piece of information, but we can hold as much information as we would like inside of our arrays. Okay, so with that, I hope you are very afraid of undefined behavior, and you will never cause it. All right, so with that, I will see you in your lab.